So, hello everyone. Today we see the charge to mass ratio of electron, which is given by J.J. Thomson first time. So, actually, he done a big experiment to get the value of charge to mass ratio, means charge by mass of electron. So, before that, they don't know about the what is the charge, what is the mass, but Directly, he calculated the charge to mass ratio value with help of an experiment. Now we see the experiment details done by him. Okay, and what are the observations he done? Okay, so it is given by J.J. Thomson. So the experiment, what he done the experiment that is observing the deflections of cathode rays. So applying electric field, this is the experiment he done. So he observing the deflection of cathode rays, applying electric and magnetic fields. So here simple, just not applying the electric field, magnetic field. He applied the electric field of different strength, magnetic field of different strength. అంటే ఎలక్ట్రిక్ ఫీల్డ్ 100 volts, 150 volts, 200 volts అట్లా. సో డిఫరెంట్ వోల్టేజ్ ఎలక్ట్రిక్ ఫీల్డ్ యూజ్ చేసుకొని he observed the deflection and the nature what is happening to the cathode rays, and he also observed the same thing applying the magnetic field also by changing the strength of magnetic field. So magnetic field కూడా కొన్ని మ్యాగ్నెటిక్ పవర్ లెస్ ఉంటుంది, మ్యాగ్నెటిక్ పవర్ హైయెస్ట్ ఉంటుంది. అంటే దాంట్లో కూడా చేంజెస్ ఉంటాయి. ఎలక్ట్రిక్ ఫీల్డ్లో వోల్ట్స్ ఎట్లా ఉంటాయో మ్యాగ్నెటిక్ ఫీల్డ్ ఆల్సో దిట్స్ కాల్ బోర్ మ్యాగ్నెటాన్స్ అంటాం. మ్యాగ్నెటిక్ ఫీల్డ్ కూడా లో మ్యాగ్నెటిక్ ఫీల్డ్, హై మ్యాగ్నెటిక్ ఫీల్డ్, వెరీ హై మ్యాగ్నెటిక్ ఫీల్డ్ యూజ్ చేయొచ్చు. అంటే he observed the deflection in the cathode rays by applying different strength of electric field and different strength of magnetic field separately. Okay, so the cathode rays applying the electric and magnetic field of different strengths. So finally he concluded, so after all observations, first I am just directly giving the value. So what are the observations hidden we see now? Okay, so on observing all these values, so all these experiments, he got that the deflections in the cathode rays are directly proportional to the strength of electric field and magnetic field. So only we discussed about this in the discovery of electron also. Actually that was exactly given, that observations are exactly given by Thomson after this experiment. He concluded that the deflections in the cathode rays are directly proportional to the strength of electric field. మనం ఎక్కువ వోల్టేజ్ అప్లై చేస్తే ఎక్కువ డిఫ్లెక్షన్స్ అవుతాయి, తక్కువ వోల్టేజ్ అప్లై చేస్తే తక్కువ డిఫ్లెక్షన్స్ వస్తాయి. ఓకే, in the same way he also given that the deflections in the cathode rays are also directly proportional to magnetic field strength. Okay, that is nothing but strength of magnetic field. Here one more important if the charge and the particles already మనకు electrons discover అయితే all electrons are having the same type of particles కాబట్టి electrons just experimental no problem, but using other rays also, not only cathode rays and other rays also, by applying electric field and magnetic field, he got the observations that the deflections in the cathode rays or any rays, here we can say the deflections in the any rays is directly proportional to the charge and the particles which are present in that rays. Already we know the cathode rays are consist of negatively charged particles which are known as electrons. So as the charge increases, their deflection also increases. Next, deflection is it is also observed deflection is inversely proportional to the mass, nothing but size. So we can't say direct size, the mass is the correct one, the mass of particles means the particle size is less, more deflection simply. So lighter particles పైన ఎఫెక్ట్ ఎక్కువ ఉంటుంది, లైటర్ పార్టికల్స్ లైట్ వెయిట్ పార్టికల్స్ ఉంటాయి, దానిపైన ఎలక్ట్రిక్ ఫీల్డ్ కానీ మ్యాగ్నెటిక్ ఫీల్డ్ కానీ ఎఫెక్ట్ ఎక్కువ ఉంటుంది. సో ఆటోమేటిక్గా మోర్ డిఫ్లెక్షన్స్ ఆర్ దేర్. ఓకే, సో దీస్ ఆర్ ద మెయిన్ అబ్జర్వేషన్స్ డన్ by J.J. Thomson in his experiment. So with the help of all these observations, he given that so this is the main point actually. So if you see the experiment, so just take it as a cathode, then take it as an anode. Okay, we know from cathode the rays are released. So the released rays are with the help of a small hole. So already we know the cathode rays are released from cathode, nothing but emitted from cathode, and they are passing towards they are moving towards anode, just using a small hole to the anode. Ikkada mana small hole cheste anode ki the cathode rays came outside. Okay, so this is terminal, this is cathode, this is anode. So take these are cathode rays. Okay, so the cathode rays can be taken outside to making a small hole, making a hole on the anode. Okay, so now these cathode rays are absorbed, by applying electric field and magnetic field. So these are the cathode rays. Okay, so already we know there is no deflection in the cathode rays in the absence of electric field and magnetic field. The electric field effect to magnetic field effect ఏది అప్లై చేయకపోతే they moves in the straight line direction. Okay, so straight line గా మూవ్ అవుతాయి. So if the electric field is applied, so electric field అంటే సో ఇది బయటకు వచ్చిన తర్వాత సో ఈ రేస్కి ఏమో ప్లేస్ అయితే we applied the electric field, means they are positive between the negative and positive terminals. Okay, means the rays pay manam electric field apply chesina with the help of a battery connections. So automatically there is a deflection takes place towards the positive side. So because already we know that the cathode rays are negatively charged particles, kabatti they are attracted towards the పాజిటివ్స్. ఓకే, నెగిటివ్ కాబట్టి పాజిటివ్స్ అట్రాక్ట్ అవుతాయి. సో మనకి ఎలక్ట్రిక్ ఫీల్డ్ మనకు పాజిటివ్ నెగిటివ్ పర్ఫెక్ట్గా ఉంటుంది కాబట్టి ఏ డైరెక్షన్లో పోతాయి, పాజిటివ్ ఏ డైరెక్షన్లో ఉంటే ఆ డైరెక్షన్లో పోతాయి. ఓకే, సో ద డిఫ్లెక్షన్ సో మీన్స్ పాజిటివ్ ఇట్ ఇస్ లైక్ దిస్, ఇట్ మే బి లైక్ దిస్, అంటే సమ్ టైమ్స్ డిఫ్లెక్షన్ మే బి వెరీ హై, సమ్ టైమ్ డిఫ్లెక్షన్ మే బి వెరీ లెస్. ఆల్రెడీ వి నో how there is a why there is a differences or takes place in the deflection angle. సో మనకి ఈ లైన్తో కంపేర్ చేస్తే డిఫరెంట్ యాంగిల్స్, ఒకసారి స్మాల్ యాంగిల్తో డిఫ్లెక్ట్ అవుతుంది, ఒకసారి హైయెస్ట్ యాంగిల్తో డిఫ్లెక్ట్ అవుతుంది. ఇట్ డిపెండ్స్ ఆన్ ద ఎలక్ట్రిక్ ఫీల్డ్, ఇట్ డిపెండ్స్ ఆన్ ద ఫీల్డ్ అప్లైడ్ ఆన్ ఇట్. Okay, so means J.J. Thomson applied the different types of field, and he different types of different strength of electric field, right? Pressure electric voltage changes to he observed the reflections. Same, he also done the same type of experiment for magnetic field. So magnetic field would apply this at the magnetic field my diagram perfect gallium. So north side both the south side both the we can't say that exactly it. బట్ నెగిటివ్లీ చార్జ్డ్ పార్టికల్స్ ఏ డైరెక్షన్లో వస్తుందో అదే డైరెక్షన్లో వస్తుంది. ఓకే, సో లైక్ దిస్ ఆఫ్టర్ దీస్ ఆల్ అబ్జర్వేషన్స్, సో హౌ దే అబ్జర్వ్ ద డిఫ్లెక్షన్స్ అంటే ఫర్ ఎగ్జాంపుల్ డిఫ్లెక్షన్ ఈ డైరెక్షన్లో అయింది, డిఫ్లెక్షన్ ఈ డైరెక్షన్, డిఫ్లెక్షన్ యాంగిల్ లెస్, డిఫ్లెక్షన్ యాంగిల్ ఈజ్ హైయెస్ట్. హౌ హీ అబ్జర్వ్ డిఫ్లెక్షన్ మీన్స్ just by taking a fluorescent screen, by using a fluorescent, for example, I'll give you know what is the meaning of so what is the nature of fluorescent screen. Fluorescent materials at general use zinc sulfide. Zinc sulfide is the best material using as fluorescent material and phosphorescent materials. So why they know which type of materials are known as fluorescent? So if any rays strike on it, there is a bright spot will be observed. Okay, that type of materials are called fluorescent. Okay, for example, we get a bright spots here forming, so automatically we can say the deflections are like this. Means with the help of these spots he was able to know the deflection angle. So after observing you have to draw these diagrams. Okay, so after all observations, this is the main point. After all observations of Thomson, he was able to give the value of charge to mass ratio, that is known as E by M, charge to mass ratio, E by M, or it is also known as specific charge. It is also known as specific charge of electrons. So what is the value of specific charge of electron? That is known as E by ME. This is ME means the mass of electron. So he concluded, he given the value like this. So there is no particular derivation for it. Coulomb per kg, or it can be written as 1.7588 into 10 to the power of 8 coulomb per grams. Okay, so this is the charge to mass ratio. This is the charge to mass ratio of electrons. We have to remember this every time. So actually after all observations he done some calculations. So the calculations are having required highly mathematical knowledge. So ఇప్పుడు మనం యూజ్ చేసే మ్యాథమెటికల్ నాలెడ్జ్తోని అంటే మన ఇంటర్మీడియట్ డిగ్రీ బేసిక్స్తో ఉన్న మ్యాథమెటికల్ ఫార్ములాస్తోని we are unable to understand the derivations. They're known as highly qualified mathematics. You just see he done the derivation. Okay, that's why in any book of intermediate level or any advanced level, we don't have the derivation. Okay, next we see the Millikans oil drop experiment. So Millikans oil drop experiment. So here, what is the purpose of Millikans oil drop experiment is this was used to get the charge on electrons. To get the charge on electrons or charge of electron. Singularly, we can write the charge of electron. So the oil drop experiment. So simply, this is a very important experiment in the general multiple type of questions. The oil drop experiment. So not only for general chemistry exams, a general basic general knowledge question also it is. The oil drop experiment was done by Millikan. So oil drop experiment is related to what? To calculate the charge of electrons. So here important. So first I just explain the uh, experiment. He used the oil drops to know the charge present on the electrons. Okay, so actually he take an electric condenser. He used an electric condenser. So electric condenser there is a two plates ఉంటాయి మనకి. Electric condenser is having two plates like this. Okay, so there is a separate chamber is there. So actually we are not giving the 100% exact diagram, just we are using a general diagram to understand the his theory. Okay, so there is two plates are there which are charged. Okay, they are connected to a condenser, means both are equally charged. So there is some holes are there. One hole is there on the upper plate. Okay, on the upper plate the charge, it is both are charged plates. The upper plate is having a hole from which he passed the drops. Okay, he passed the drops. These are the oil drops. So actually the air is present in it. So here no need to draw the diagram for you, just understand it. Okay, so simple thing electric condenser you just see he passed the oil drops one by one oil drops passation. So what he wants to calculate is total ఇక్కడ ఆయిల్ డ్రాప్స్ వేసిన తర్వాత ఈ ఆయిల్ డ్రాప్స్ పైన వచ్చే ఎలక్ట్రిక్ చార్జ్, ఫర్ ఎగ్జాంపుల్ జస్ట్ ఇట్ ఈస్ ఎన్ ఆయిల్ డ్రాప్ అనుకుందాం. సో దిస్ ఈజ్ అప్టెన్ ఫ్రమ్ ద అప్పర్ ప్లేట్. సో ఈ అప్పర్ ప్లేట్ నుంచి ఈ డ్రాప్ వచ్చింది అనుకుందాం. ఓకే, so there is also different equipments are there which is connected to this chamber. There is a electric microscope. So microscope is there. So there is also one other thing, one a way to pass the x-rays. And actually the total ఇన్సిడెంట్ ఏముంటుంది మనకి బిఫోర్ ద ఎక్స్పెరిమెంట్. సో దాంట్లో ఉండేది మనకి ఎయిర్, టోటల్గా గ్యాప్ ఉందంటే ఎయిర్. దే నాట్ యూజ్డ్ ఎనీ లిక్విడ్ బిఫోర్ ద అంటే ఆయిల్ డ్రాప్ పంపించకపోతే దాంట్లో సింపుల్ వేకెంట్ ప్లేసే ఉంటుంది. ఓకే, వేకెంట్ ప్లేస్ మీన్స్ నాట్ వ్యాక్యూమ్, ఎయిర్ ఈజ్ ప్రెసెంట్. సో ఆ ఎయిర్ ఈజ్ కన్సిస్ట్ ఆఫ్ సమ్ గ్యాసెస్. అయితే దట్ గ్యాసెస్ ఆర్ అయోనైజ్డ్. ద గ్యాసెస్ ఆర్ అయోనైజ్డ్ బై పాసింగ్ x-rays. Meaning that x-rays are having that type of capacity to ionize the gases. So it is also one of the properties of cathode rays. When cathode rays are passed through gases, the gases get ionized. In the same way మనం x-rays కూడా ఈ ఎయిర్లో అంటే ఇప్పుడు ఆయిల్ డ్రాప్ ఏం పంపించకముందు దాంట్లో ఆ వేకెంట్ ప్లేస్ మీన్స్ విచ్ కన్సిస్ట్ ఆఫ్ ఎయిర్. సో దాంట్లోకి x-rays పంపించినప్పుడు ఏమైందంటే ఎయిర్ గెట్ అయోనైజ్డ్. అంటే ఎయిర్లో ఉన్న గ్యాసెస్ గెట్ అయోనైజ్డ్. సో గెట్ అయోనైజ్డ్ మీన్స్ దే గెట్ సమ్ చార్జ్డ్. ఓకే, ఎంతో కొంత చార్జ్ వస్తుంది. అయితే ఎప్పుడైతే ఆయిల్ డ్రాప్స్ పంపించినవో ఆయిల్ డ్రాప్స్ ఆర్ ఆల్సో గెట్ చార్జ్డ్. వెరీ సింపుల్ లాజిక్. సో ఎయిర్ ఈజ్ అయోనైజ్డ్ విత్ ద హెల్ప్ ఆఫ్ ఎక్స్రేస్. సో ఎక్స్రేస్ పంపించిన తర్వాత దీంట్లో టోటల్ కన్సిస్ట్ ఆఫ్ ఎయిర్. సో ఎయిర్ గెట్ అయోనైజ్డ్. సో ఎయిర్ అయోనైజ్ అయిపోయిన తర్వాత ఓకే ద ఎయిర్ okay so the air present in the chamber was ionized by passing the beam of x-rays. So x-rays with the help of microscope, actually microscope is also not 100% suitable, so he also used a telescope. He also used a telescope to observe it. Telescope is a better one when compared to the microscope. And the telescope you just say he observed what is happening at the inside, and he also was able to calculate the charge present on the each drop downwarding from the upper plate to the chamber. Okay. So how oil drops are get charged? Oil drops man etla charge, how they get the charge means they make some collisions with the charged ions of gases. So air lo manaki gases ఉంటాయి. సో ఎయిర్లో ఉన్న గ్యాసెస్ ఆర్ అయోనైజ్డ్ బై పాసింగ్ ద ఎక్స్రే బీమ్. సో ఎక్స్రే బీమ్ పంపించి ఎయిర్లో ఉన్న గ్యాసెస్ అయోనైజ్డ్ అంటే గ్యాస్లో గ్యాస్ అయాన్స్ లాగా ఫామ్ అవుతుంది. అయాన్స్ ఆర్ హ్యావింగ్ సమ్ చార్జ్. సో ఇప్పుడైతే ఆ చార్జ్ ప్లేస్లోకి ఏం పంపిస్తున్నాం, ఆ చార్జ్ ప్లేస్లోకి హీ పాస్డ్ ద ఆయిల్ డ్రాప్స్. సో ఆయిల్ డ్రాప్స్ పంపించినప్పుడు సో ఆయిల్ డ్రాప్స్ ఆర్ ఆల్సో గెట్ చార్జ్డ్. Oil drops are also get charged. So how they get the charge means they made some collisions with the charged particles of air. Airలో ఉన్న charged particlesతో పార్టికల్ ఆయిల్ డ్రాప్ వచ్చింది కాబట్టి ఆటోమేటిక్గా వాటితో కొలీజన్స్ ఎయిర్లో ఉన్న అయాన్స్ మొత్తం ర్యాండమ్గా మూవ్ అవుతుంటాయి కాబట్టి సో దే డూ సమ్ కొలీజన్స్ విత్ ద ఆయిల్ డ్రాప్స్. సో ఆటోమేటికలీ that oil drops are also get charged. So ఇప్పుడు now what Millikan done is he observed how much charge is obtained, by the oil drops. Okay, so he also done this experiment means మనకి ఇక్కడ ఆయిల్ డ్రాప్ వస్తుంది. అయితే ఈ ఆయిల్ డ్రాప్ స్పీడ్ మనకి స్లోగా ఆయిల్ డ్రాప్స్ రావచ్చు, ఫాస్ట్గా ఆయిల్ డ్రాప్స్ రావచ్చు. So oil drops speed also can be controlled with the help of the electric charge. ఈ charge base చేసుకొని so oil drops speed he was able to control. Okay, next after all these experiments, doing this experiment many times he observed and at different times different electric field apply చేసి he concluded that all oil drops are getting charged. That is the multiple integral of 1.66 into 10 to the power of minus 10 coulombs. Okay, sorry, minus 19 coulombs. He observed after all these observations he done. He concluded that after all observations he concluded that the charge on the droplet is the multiple integral of 1.66 into, actually generally 1.60 something is there, we are simply we write 1.6 into 10 power minus 19 coulombs. అంటే వచ్చిన ఆయిల్ డ్రాప్స్ అన్నిటికి ఇంతే చార్జ్ ఉందంటే it is not like that. The charge on the oil drops Q is called N into E. What is the E means? He got 1.6 into 10 power minus 19 coulombs. Means some are having 2 into 1.6 into 10 power minus 19. Some are having 3 into 1.6 into 10 power minus 19 coulombs. అంటే వాటన్నిటి మనం వచ్చిన అన్ని చార్జెస్ని దేతో డివైడ్ చేస్తే he got the simple integers. అంటే by dividing that all charges with 1.6 into 10 power minus 19 he got the simple integers 1 2 3 4. Here n equal to 1, 2, 3, like this. Means so after all, he was ready to conclude that all are having the charge is the multiple integral of 1.6 into 10 minus 19 coulomb. So that's why he given the charge of electrons are 1.6 into 10 minus 19. And the అంతకంటే least not like that is only the least charge. So next వచ్చిన charges అన్ని ఎటు ఎట్లా ఉన్నాయి. సో ఉంటే ఈ ఛార్జ్కి ఇంటూ 2 times 3 times 4 times 5 times సో ఇంకా ఎక్కువ టైమ్స్ కూడా ఉండొచ్చు. But what is the basic value he absorbed is 1.6 into 10 minus 19 coulombs is the charge of electron. So finally he concluded that the charge of electron is this one. Okay, so first we read some points about it. Okay, these are the main points. So with the help of this we can understand easily about this experiment. So here, see the first one, oil drops are taken in the form of mist, not exactly 100% liquid. They are taken in the form of mist, means to make the movement of them somewhat slow. So the droplets are allowed to enter through a tiny hole in upper plate of electrical condenser. Like the movement of droplets are also viewed through the telescope connected to the chamber. Next, at this time, the forces are acting on the oil droplets are gravitational force is common one, electrostatic attraction because they are moving in the electric chamber, and also viscous drag. Viscous drag means so its oil is having somewhat more viscous when compared to the water. Okay. So after passing the X-rays into the beam, X-rays into the chamber, the air get ionized in it. Okay. So the charge obtained by the droplets is nothing but due to the collisions of gaseous ions which are ionized due to the passage of X-rays. And the fall of oil droplets also depend upon the charge, polarity, and also voltage across the plates. So after all these experiments observations, Millikan was able to conclude the magnitude of electrical charge that is taken as a Q is always integral multiple of E, that is Q equal N into E. So what is that E? We know the value that. So after doing the experiment observations many times with the help of a highly mathematical derivation, he was able to calculate the charge of an electron is 1.6 into 10 minus 19 coulombs. So this is the oil drop method by Millikan to find the charge of an electron. Next, after knowing the charge to mass ratio given by the Thomson and also the charge given by the oil drop method by Millikan, we are also able to write the charge, the mass of electron. So now we see the mass of electron. Okay. So with the help of E by M value, so mass of electron can be taken if you see E by M charge to mass ratio of electron by mass of electron. So very simple, on this directly we get mass of electron. It means mass of electron is charge, the ratio of charge to mass to the mass. So finally we get the mass of electron. So mathematically we do it. So just wait, not like this. We have to this totally we written the opposite direction. Okay. So to get the mass of electron, we have to write the charge by charge to mass ratio. So it's not exactly opposite ratio, not like that. Charge to mass ratio. Here we will get exactly mass. Okay. So therefore mass of electron equal to charge. Charge we are taking as a symbol E and charge to mass of electron. So here we get cancelled. So means on using this formula we can do we can calculate the mass of electron. What is E? What is the charge obtained for electron? 10 power minus 1.6 into 10 power minus 19 coulombs. Yes, what is the charge to mass ratio according to the Thomson? It is given as so earlier it is taken as in coulombs. Here also we are taking in terms of coulomb per kg. Okay, coulomb per kg. So here we get the answer in terms of kgs. It is in coulombs. Coulombs get cancelled. So on this overall calculation, we will get to 9.1094 something into 10 power minus 31 kilograms. Generally, it is taken as a 9.109. Generally taken as 9.11 into 10 power minus 31 kgs, or it can be written in terms of grams also. 9.11 into 10 power minus 28 grams. Okay, so these are the charge of electrons, mass of the electrons, and E by M of the electrons. Okay, so after writing all these, just put a note and write the charge of electron, charge of mass of electron, charge to mass ratio of electrons. Okay, you have to remember for many years to this mass of electrons always. Okay.